Okay, I was speaking about the the period, not the period, the domain. Okay, all possible x values of a function, right? So for this function, for this function, all the possible x values of this function, you can see it starts from 0 and it ends at 360. So the domain of this function is going to be x is an element of 0 up to 360. So these are all the possible x values of this function. So now let's talk about the range, because this is the domain. Okay, the range is all the possible y values of the function. So this is where you find the range on the y-axis. These functions, it it has the minimum at -1 and it also has the maximum at 1. So all the possible y values of these functions is from -1 to y. Okay, so we can move on to a cosine function. So for a cosine function, it is just the same with um with the sine function. So let's say we have f of x is equals to a cos x plus q. So this is how you're going to have it. So these are the y-axis and these are the x-axis. So this is how you're going to have it. Let's say it starts from 1. You're going to have something like this ending at 360. So from this side also you're going to have something like this ending at -360 degrees. The minimum is -1 and the maximum is 1, right? On this function, the amplitude is going to be 1 and the vertical shift, there's no vertical shift, it is not shifted uh, in the y-axis, so the vertical shift is 0. So you're having a function y is equal to the cosine of x, right? And let's talk about the domain. The domain of this function is x is an element of, it starts from -360 and it ends at 360. So these are all the possible x values of this function. So now let's talk about the range. The range of this function, it has the minimum at -1 and it has the maximum at 1. Okay. So now we can move on and also talk about the tan function. Okay, let me just find this phrase where I can speak about the tan. Let's speak about the tan here. Okay, let's say you have a function f of x is equals to a tan x plus q, right? Okay. Uh, for this one, you have asymptote. Okay. For tan, you have asymptote. So you'll have an asymptote at 90, and you also have an asymptote at 270. Okay. So the graph is never gonna touch the asymptote. You know what is the definition of an asymptote? An asymptote um is the imaginary line that the graph approaches, but it never touches, right? There's an imaginary line the graph approaches. You see here, it approaches the imaginary line, but it will never touch this line. It is just going to be closer to that line. In imaginary line, the graph approaches, but it never touches. I know that my drawing is not that good, but then as long as you can see. Okay, here we have 90, and here we have 2 270 here. So we're gonna have something like here, if it's 360, we're gonna have something like this. Then here, if it's 360, we're gonna have okay, let me go back. This is 360, then also there is 360. Okay, so these are the asymptotes. So you have x is equals to 90 degrees. X equals to plus or minus 270 degrees. These are the asymptote of this function. Okay, Q still represent the vertical shift, and A still represent the amplitude. Okay, and the other thing that you must pay attention to is the period. The period of tan is different from cos. The period of tan is 180 degrees. So this graph actually repeats itself after every 180 degrees. If you can see here, it is from 270 to 90, then from 90 to 90, which is 180. So this graph repeats itself after every 180 degrees. So that's why the period for tangent is 180 degrees. It has the asymptote at plus or negative 90. Okay. And then if it starts from 360 and it ends at 360, then you can say the the domain is from negative 360 to 360. But then check something. For the range, you can see this graph is going up to infinity. Even this side is going up to infinity. So y is an element of real number. That is our range. Okay, I've spoken about a couple of things, and I think we can start answering some of the questions. Okay, we have a graph here. Okay, let's see if we can answer some of these questions here. We are given a cosine function, f of x is equals to negative 2 cos x, and it is thrown from 0 to 360 here. So we already know what is our domain. Our graph, all the possible x values are from 0 to 360. And our range, we can see it starts from negative 2 and it ends at 2. 6.1. What is our the amplitude of f? The amplitude is the distance from here to here. It is multiplied by negative negative 2, right? So our amplitude is equals to negative 2. You can decide to calculate it, max, min, over 2. So you can have the maximum is 2 minus the minimum is negative 2 over 2, right? Okay. The maximum is 2 minus the minimum is negative 2. So our amplitude is 2 because it's going to be 4 minus 4. So our amplitude is 2. 6.2. Write down the minimum value of f of x plus 3. So there is a vertical shift here. So if this graph is shifted 3 units up, right? We're going to shift this minimum. This is the minimum value. We're going to shift it 3 units up. So it's going to move from here 1 unit up, 2 unit up, 3 units up. So now our minimum value, it is going to be at 1. So our minimum value for f of x is going to be at 1, 6.3. On the same axis, draw g, where g of x is the sine. Okay, let's find a rubber, then draw the graph. Okay. We have a vertical shift and our new axis is 1, right? Our new axis for the graph is going to be 1. So let's say now we have our new axis at 1 here for our new graph. So it is going to be we're going to move from 1 all the way to 180 and move from 180 to 270, and we're going to end up at 360. That is the graph of G. Okay. Now they say use the graph to determine the following. 6.4. They say what is the value of 180 degrees minus g of 180 degrees. So let's look for this point. F of x at 180, which is this point, it is 2, right? It is 2 minus g of x at 180, which is this point, it is 1. So the answer here is 2 minus 1, which is 1. So now they say for which values of x will f multiplied by g be greater than 0? What it actually means is that for which values of x is the product of these two functions greater than 0. So we're going to look for the functions where the other one is they're both either positive, or they're both either negative. So if you can see from here, that's where they are both positive, and it ends here, that's where they are both positive. from 0 to 90, the other one is negative, the other one is positive. From 270 to 360, the other one is negative, the other one is positive. So the product of negative and positive is negative. So we're not looking for that. We're looking for a product of the function where is either both of them are negative or both of them are positive. So we only have both of them positive from 90 to 270. So the x values are going to be between 90 degrees to 270 degrees. It's 2.4.2, 2.4.1. Okay, let's go to 6.5. Okay, the 6.5 say the graph of f is reflected about the x-axis. This is the x-axis, right? If you reflect the graph of x about the x-axis, right? Which this is the graph of f of x. So the graph is no longer going to be negative now, it is going to be positive. This is how the graph is going to look like if you reflect it about the x-axis. It is no longer negative but positive. It is the mirror image of the graph. But then there's another important information. They say you reflect the graph and move 3 units down. So now there is a vertical shift, which is 3 units down. They now want us to write the function h. H of x is the reflection of the function f of x. Now we're going to have 2 cos x, but it also has to move 3 units downwards. So we have to move 3 units down. This is the new equation for the function h of x. This is 6.5.1. So let's go to 6.5.2. It says the range of h, determine the range of h for interval 0 to 360. So because now we're moving this function 3 units down, we're going to have the maximum value at, so we're moving it 1 unit down, 2 units down, 3 units down. Okay, we're going to have the maximum value here at -1, right? And we're also going to have the minimum value at negative. We're going to have -3, which is 1 unit down, -4, 2 units down, -5, 3 units down. So now we're going to have the minimum value at -5. So our range is going to be, y is an element of real number, or we can say it is an element of -5 to -1. Okay. We can also quickly do this function. This question, which is question number 5. We can also quickly do this question. The question number 5.1, it says, sketch the graph of f and g up to 270. So let's say we have a graph like this. We have a Cartesian plane like this, right? This is y and this is x. and we're starting from 0 to this is, let's say this is 180, and let's say this is 360, which means here is 270 and here is 90, right? Okay, the okay, let's say here is 1 and here is 2. Here is 1, -1, and here is -2. So we have to draw our function sine of x minus 1, right? So we have a vertical shift now. Our new axis for f is going to be at y is equals to -1, and the function is is a sine. So we're going to have, this is how our graph is going to look like. And we have to stop at 270 because they have given us the domain here. So now we can also draw the equation, the function for g of x, which is 2 cos x. So 2 cos x is going to start from here, right? Is going to start from here all the way to okay. It's supposed to start from here. Well, we have -2, so it's gonna start from here going down to here, then it's supposed to go up, but then it's gonna end here. It is going to end at 270. Here it is 180. Okay, we're done with sketching the graph. 5.2, they say write down the amplitude of G. Which one is G? G is this one. The amplitude is 2, right? Amplitude is equals to 2. You can calculate it if you want. 5.2.2. Write down the range of f. This is f, and this is G. F, the maximum is 0 and the minimum is -2. So the range is y is an element of -2 to 0. Then 5.3, it says use the graph to determine the following. Number of solution for which f of x is equals to g of x, right? We want the values of x for which these functions are going to be equal. They are equal here at 90, and they are also equal here. So there are 2 points where these graphs are equal. I don't know if I have drawn it correctly, but then okay, from here is 0, then to here, then after I'll have 270, then after 270 I'll have 360. Okay, then this is another point where the functions are equal. So you can say x is equals to 90 degrees. Okay, the last question says values of x for which from interval 0 to 180, for which sine of x and cosine are equal. So sine of x is going to be, we need, if we have sine of x, this is how sine of x is gonna look like up to 180. This is sine of x up to 180. Then cosine 2 cosine shifted 2 units up. It is going to look like this. So now we're going to have a new shift here, which is going to be like, we're going to start at 4, somewhere here at 4. So now we're going to have something like, okay, this is 90. So we're gonna have something like, okay, it's supposed to be, okay. So these points are going to be equal at 180. Or there's going to be a point here where they are going to be equal. Somewhere here, the points are going to be equal. If you want, you can solve it. But then the point here where it is equal is between 90 and 180. It is going to be equal. Okay. I think I'm done with the lesson.